Welcome to our deep dive into unsupervised learning, a fascinating branch of machine learning where algorithms work without labeled data. Unlike supervised learning, which relies on input-output pairs, unsupervised learning explores raw data to uncover hidden patterns and structures. This approach is especially useful when we have large amounts of data, but little to no information about the outcomes. Throughout this video, we'll explore how unsupervised learning works, its main techniques, and real-world applications. Let's begin by understanding what makes unsupervised learning unique and why it's so important in today's data-driven world. Supervised learning is a type of machine learning where algorithms analyze and interpret data without any explicit instructions or labeled outcomes. The goal is to find patterns, groupings, or structures within the data itself. This method is particularly valuable when we don't have predefined categories or answers. Instead, the algorithm learns from the data's inherent characteristics. Unsupervised learning is widely used in fields like customer segmentation, anomaly detection, and data compression. By letting the data speak for itself, we can uncover insights that might otherwise remain hidden. One of the main differences between unsupervised and supervised learning lies in the data used. Supervised learning requires labeled data, where each input has a corresponding output. In contrast, unsupervised learning works with unlabeled data, seeking to identify patterns or groupings without any prior knowledge of the results. This distinction makes unsupervised learning more flexible but also more challenging, as there's no clear feedback to guide the algorithm. Understanding this difference is crucial for choosing the right approach for your data analysis tasks. Clustering is one of the most common techniques in unsupervised learning. It involves grouping data points based on their similarities, so that items in the same group are more alike than those in different groups. For example, clustering can help businesses segment customers by purchasing behavior or group similar documents together. The algorithm doesn't know the categories in advance, it discovers them by analyzing the data's features. This makes clustering a powerful tool for exploring large, unstructured datasets. Several clustering algorithms are widely used in unsupervised learning. K-means is perhaps the most popular, dividing data into a set number of clusters based on similarity. Hierarchical clustering builds a tree of clusters, allowing for more flexible groupings. DBCN is another method that identifies clusters of varying shapes and sizes. Each algorithm has its strengths and is suited to different types of data and analysis goals. Choosing the right clustering method depends on your specific needs and the nature of your dataset. Dimensionality reduction is another key technique in unsupervised learning. It involves simplifying complex datasets by reducing the number of variables or features while retaining important information. This process helps make data easier to visualize and analyze, especially when dealing with high-dimensional data. Techniques like principal component analysis (PCA) and TSNE are commonly used for this purpose. By focusing on the most relevant features, dimensionality reduction can reveal underlying patterns that might be hidden in the noise. Principal component analysis, or PCA, is a popular dimensionality reduction technique. It works by transforming the original features into a new set of variables, called principal components, which capture the most variance in the data. By focusing on these components, PCA reduces the dataset's complexity while preserving its essential structure. This makes it easier to visualize and analyze large datasets, and can also improve the performance of other machine learning algorithms. TSNE, or T-distributed stochastic neighbor embedding, is another dimensionality reduction technique, especially useful for visualizing high-dimensional data. Unlike PCA, TSNE focuses on preserving the local structure of the data, making it ideal for creating 2- or 3-dimensional maps that reveal clusters and relationships. This method is widely used in fields like genomics and image recognition, where understanding complex data structures visually is crucial. Association rule learning is a technique used to discover interesting relationships or associations among variables in large datasets. A classic example is market basket analysis, where retailers analyze which products are frequently bought together. Algorithms like Apiary and ECLAT help identify these associations, enabling businesses to make data-driven decisions about product placement, promotions, and recommendations. This technique is widely used in e-commerce and retail industry. Anomaly detection is another important application of unsupervised learning. It involves identifying data points that deviate significantly from the norm. These outliers can indicate fraud, errors, or rare events. Since anomalies are often unknown in advance, unsupervised learning is ideal for this task. Algorithms analyze the data's structure to flag unusual patterns, helping organizations detect issues early and take corrective action. Supervised learning is widely used in customer segmentation, where businesses group customers based on shared characteristics or behaviors. By analyzing purchase history, demographics, or online activity, algorithms can identify distinct customer segments. This enables companies to tailor marketing strategies, personalize offers, and improve customer satisfaction. Effective segmentation can lead to better engagement and increased sales. Supervised learning techniques are also used in image compression. By identifying patterns and redundancies in image data, algorithms can reduce file sizes without significant loss of quality. This is especially important for storing and transmitting large volumes of images efficiently. Techniques like clustering and dimensionality reduction play a key role in this process, making it possible to balance image quality and storage needs. Supervised learning is essential in text mining and topic modeling, where algorithms analyze large collections of documents to uncover themes and topics. Techniques like latent Dirichlet allocation, LDA, automatically group words and documents based on their content, making it easier to organize and summarize information. This is widely used in news aggregation, academic research, and content recommendation systems. The field of genomics, unsupervised learning helps researchers analyze gene expression data. By clustering genes with similar expression patterns, scientists can identify biological pathways and understand disease mechanisms. This approach is crucial for discovering new drug targets and advancing personalized medicine. Unsupervised learning enables researchers to make sense of complex, high-dimensional biological data. Supervised learning is also used to analyze social networks. By examining connections and interactions between users, algorithms can identify communities, influencers, and trends. This information is valuable for marketing, public relations, and understanding social dynamics. Social network analysis helps organizations map relationships and uncover hidden structures within large groups. Market basket analysis uses unsupervised learning to discover which products are frequently purchased together. Retailers use this information to optimize store layouts, design promotions, and recommend products to customers. By analyzing transaction data, algorithms can reveal associations that drive sales and improve the shopping experience. This technique is a cornerstone of modern retail analytics. Financial institutions use unsupervised learning to detect fraudulent transactions. By analyzing patterns in transaction data, algorithms can flag unusual activity that may indicate fraud. Since fraudulent behavior is constantly evolving, unsupervised methods are well suited to adapt and identify new types of threats. This helps banks and businesses protect their assets and customers. Recommender systems often use unsupervised learning to suggest products, movies, or content to users. By analyzing user behavior and preferences, algorithms can group similar users or items and make personalized recommendations. This approach is widely used by streaming services, online retailers, and social media platforms to enhance user experience and engagement. Unsupervised learning can assist in data preprocessing and cleaning by identifying anomalies, duplicates, or missing values. Clustering and dimensionality reduction techniques help streamline datasets, making them more suitable for further analysis. This step is crucial for ensuring data quality and improving the accuracy of downstream machine learning models. Supervised learning offers several advantages. It can handle large, unlabeled datasets and uncover patterns that might not be apparent through manual analysis. This approach is flexible and adaptable, making it suitable for a wide range of applications. Additionally, unsupervised learning can reveal insights that drive innovation and support data-driven decision-making across industries. Despite its strengths, unsupervised learning comes with challenges. Without labeled data, it can be difficult to evaluate the quality of the results. Algorithms may also struggle with noisy or irrelevant features, leading to less meaningful groupings. Choosing the right technique and interpreting the findings requires expertise and careful analysis. Understanding these limitations is key to successful implementation. Feature selection plays a critical role in unsupervised learning. By choosing the most relevant variables, we can improve the performance and interpretability of algorithms. Irrelevant or redundant features can obscure patterns and reduce accuracy. Careful feature selection ensures that the analysis focuses on the most important aspects of the data, leading to better results. Evaluating unsupervised learning models is challenging because there are no ground truth labels. Instead, we use metrics like silhouette score, Davies-Bouldin index, or visual inspection to assess the quality of clusters or groupings. These methods help determine whether the algorithm has found meaningful patterns, but interpretation often requires domain knowledge and experience. Let's look at a real-world example: customer segmentation for a retail business. By applying clustering algorithms to transaction data, the company can identify groups of customers with similar purchasing habits. This allows for targeted marketing campaigns, personalized offers, and improved customer retention. Unsupervised learning makes it possible to uncover valuable insights from raw data, driving business growth. Another example, a bank uses unsupervised learning to detect fraudulent transactions. By analyzing transaction patterns, the algorithm can flag unusual activity that might indicate fraud. This proactive approach helps the bank respond quickly to threats and protect its customers. Unsupervised learning is essential for identifying new and evolving types of fraud. News aggregator uses unsupervised learning to organize articles by topic. By analyzing the content of each article, the algorithm groups similar stories together, making it easier for users to find relevant news. This approach streamlines information discovery and helps users stay informed about topics that matter to them. Photo sharing platform uses unsupervised learning to compress images before uploading. By identifying patterns and redundancies, the algorithm reduces file sizes without sacrificing quality. This saves storage space and speeds up uploads, enhancing the user experience. Unsupervised learning makes large-scale image management more efficient. In medical research, unsupervised learning helps scientists analyze gene expression data. By clustering genes with similar activity, researchers can identify disease markers and potential treatment targets. This accelerates the discovery of new therapies and advances personalized medicine, ultimately improving patient outcomes. Social media platforms use unsupervised learning to analyze user interactions. By mapping connections and communities, algorithms can recommend friends, suggest groups, and identify trending topics. This enhances user engagement and helps platforms deliver more relevant content to their audiences. Internet of Things, IoT, generates vast amounts of data from connected devices. Unsupervised learning helps make sense of this data by identifying patterns, anomalies, and trends. This enables smarter decision-making in areas like predictive maintenance, energy management, and smart cities. Unsupervised learning is key to unlocking the full potential of IoT. Healthcare organizations use unsupervised learning to analyze patient data, identify disease patterns, and improve treatment outcomes. By clustering patients with similar symptoms or responses to treatment, doctors can personalize care and develop more effective therapies. This approach supports evidence-based medicine and advances healthcare innovation. Cybersecurity experts use unsupervised learning to detect threats and vulnerabilities in networks. By analyzing network traffic and user behavior, algorithms can identify unusual patterns that may indicate attacks or breaches. This proactive approach helps organizations strengthen their defenses and respond quickly to emerging threats. Manufacturers use unsupervised learning to monitor equipment performance and detect anomalies. By analyzing sensor data, algorithms can predict maintenance needs and prevent costly breakdowns. This approach increases efficiency, reduces downtime, and supports the shift towards smart manufacturing and Industry 4. Marketers leverage unsupervised learning to segment audiences, analyze campaign performance, and optimize strategies. By uncovering hidden patterns in customer data, algorithms help businesses deliver more relevant messages and improve return on investment. Unsupervised learning is a powerful tool for data-driven marketing. Transportation companies use unsupervised learning to optimize routes, predict demand, and improve logistics. By analyzing traffic patterns and shipment data, algorithms can identify bottlenecks and recommend efficient solutions. This leads to faster deliveries, lower costs, and better service for customers. Educational institutions use unsupervised learning to analyze student performance, group learners by ability, and personalize instruction. By identifying patterns in assessment data, teachers can tailor lessons to meet individual needs and support student success. This approach fosters more effective and inclusive education. Entertainment platforms use unsupervised learning to recommend movies, music, and games. By analyzing user preferences and consumption patterns, algorithms can suggest content that matches individual tastes. This keeps users engaged and helps platforms stand out in a crowded market. E-commerce companies use unsupervised learning to analyze customer behavior, optimize product recommendations, and detect fraudulent activity. By uncovering patterns in browsing and purchase data, algorithms help businesses increase sales and enhance the shopping experience. Energy companies use unsupervised learning to monitor consumption patterns, detect anomalies, and optimize resource allocation. By analyzing data from smart meters and sensors, algorithms can identify inefficiencies and recommend improvements, leading to cost savings and sustainability. Farmers use unsupervised learning to analyze crop data, monitor soil conditions, and optimize yields. By clustering fields with similar characteristics, algorithms help farmers make informed decisions about planting, irrigation, and fertilization. This leads to higher productivity and more sustainable agriculture. Insurance companies use unsupervised learning to segment policyholders, detect fraudulent claims, and assess risk. By analyzing claim data and customer profiles, algorithms can identify patterns that inform pricing and underwriting decisions. This helps insurers manage risk and improve profitability. Real estate companies use unsupervised learning to analyze property data, identify market trends, and segment buyers. By clustering properties with similar features, algorithms help agents match buyers with suitable homes and forecast market changes. This supports smarter investment and sales strategies. Sports teams use unsupervised learning to analyze player performance, group athletes by skill, and develop training programs. By uncovering patterns in game data, coaches can make informed decisions about strategy and player development. This leads to better performance and competitive advantage. Artists and designers use unsupervised learning to generate new ideas, analyze styles, and create unique works. By clustering artworks or analyzing patterns in creative data, algorithms can inspire innovation and support the creative process. This intersection of technology and art opens up exciting possibilities for the future. Supervised learning is a powerful tool for discovering patterns, making sense of complex data, and driving innovation across industries. As data continues to grow, the importance of unsupervised techniques will only increase. By understanding its methods, applications, and challenges, we can harness the full potential of unsupervised learning to solve real-world problems and shape the future of technology.